for intelligent databases is a software technology that is deployed in between application servers and database servers. It's a transparent deployment so that you don't have to make any modifications to applications or any modifications to databases in order to deploy IDB. Once you deploy IDB, which generally takes about 15 minutes, the logging and analytics immediately kick in. And that's really the basis for doing all sorts of stuff with IDB. The first is using the analytics for instant troubleshooting. Now in today's world, if there's a frequent slow query that's lost in the morass of queries that are hitting the database, generally you have to review sets of logs. Maybe it shows up on the slow query log, maybe it doesn't. IDB instantly tells you what the frequent slow query or frequent slow queries are to dramatically reduce troubleshooting time. Then, with that visibility, we now give customers the ability to architect and scale and provide higher availability for their database environment. We're not going to get into a lot of these features and functions here, but now the database engineering is pulled out of the app into IDB, allowing you to do read-write split, dynamic load balancing, horizontal scale out. We'll talk a little bit about surge protection because that is part and parcel with the analytics. The analytics also allow you to take advantage of the SQL filtering capabilities for some better security, as well as the ability to do caching in the IDB layer and main memory. And we're going to talk about that as well today. And the key is, as I mentioned, it's a transparent insertion. You never have to modify an application or a database instance to deploy IDB and or to take advantage of all these features and functions. And IDB is software, so it can be deployed on any x86 server to turn that server into an appliance. We also ship appliances, or you can deploy IDB on a hypervisor as a virtual machine. Okay, so that's a little bit about the deployment and how IDB is deployed. Now, in terms of driving ROI from analytics, there's really three primary areas where our customers drive very strong return on investment. The first is just faster time to troubleshoot. We're actually going to show you customer data from two of our international customers, Yatra.com, which is an online hotels booking engine, and India Infoline, which is a large financial services organization in India. And we're going to show you how their analytics dramatically reduce troubleshooting times. And the less time to troubleshoot means the more time to optimize. And we've had a number of customers, in addition to these, customers like Kixeye and Weather Decision Technologies, that have actually been able to forego hiring an additional IT operations person or an additional DBA because before IDB, it would require a full headcount to be able to go through all the laborious process of gathering this data, sifting through mountains of data, and analyzing. We provide that to you instantly. So this acts as a real friendly tool for operations and DBAs and application developers as well. We're also going to talk about how analytics gives you that ability to do transparent caching so that you can scale your existing database infrastructure by offloading that database infrastructure with transparent query level caching. Again, no modifications ever to applications in order to do this. And so this allows you to do a lot more with less. Buy fewer servers in the future, buy less licenses, and do more with less. Plus, in certain circumstances, depending on the type of application, the faster response times can drive more revenue. That, of course, is dependent on each and every customer, whether or not they're supporting revenue generation activities through the database. And then the third major area is better security, analytics driving the ability to utilize the security features of IDB for higher availability and uptime. And then we also do want to mention surge queuing and how that works and how that's used through viewed through the analytics. So this is what we're going to be covering now. But first, I'd like to turn it over to Mr. Deepak Patel, who will actually show you the live IDB system, the logging, and the analytics from our customers.
Yeah, thank you, Justin. So what I have here is a live IDB traffic, the traffic going through the IDB at this point. And as in pure demo fashion, the load just ended. I'm just going to restart the workload. It's not take too long. So what I'm showing here is all the traffic that's going through IDB. So we show a read-write split, which we are showing that it's load balancing between multiple servers. We're showing that it's actually engaging the search queue. So today's demo is more about analytics. So what the IDB does when traffic is passing through is it collects extensive log information about the query itself. So the query fonts are too small here. I've copied one of these into a Word file here. So what the IDB logs is which client issued that query, what was the username, password, the username and the database that came for that particular query, which exact database server was serving that query. A lot of such metadata, including the query itself, whether it was part of a transaction. So all that is getting logged. The challenge here is it becomes a big data problem. It's nice that we are logging all of these things, but then to make sense out of this will take a little bit more effort. So we went a step ahead and actually started deduplicating all of these logs so that it's actually very useful, instantaneous analytics for troubleshooting purposes. So I'll just go into analytics, which is basically the deduplicated logs. And this is how the deduplicated logs are going to look like. For any particular hour, you're going to have refresh. I'm just waiting for the screen refresh to happen. Yeah. So this is how the deduplication will look like. So where we are not going to show you the million lines of log entry, we are actually going to show you only the entries that, the deduplicated entries that matter, in the sense that here, if you look at the 4 quadrants, the way the quadrants are laid out is it's based on frequency of execution and the time it took to execute. So this is the frequency. That means how many times the query executed in that hour. And this is the time it took to execute relative to the other queries. So in this perfect 4-quadrant graph, you only see 2 queries, which is the select star from table 1 with the limit values that keep changing, and then insert. This is just the demo traffic that we have. But the key thing here is we are not showing you the million lines of log. We are showing you the queries based on how frequently they're executing and how slow they were with respect to the other one. So you have the 4th quadrant, which is the frequent but slow query, which is the most important one. Then you have the infrequent slow query ones. You have the infrequent fast, and you have the frequent fast queries. So the objective here is to move queries from your frequent but slow category to the frequent but fast, because changing the query execution itself changes your application performance. So with that, we'll go into live the customer data that we have collected from 2 of our marquee customers. One of them that I'm going to show right now is India Info Online. For all practical purposes, you can consider them as like a Yahoo Finance of India. So their primary challenge was they had to differentiate themselves from the other financial services in the market by giving near real-time quotes. The challenge with doing that was you had to basically query the database often, and you had to figure out how to basically improve the performance. So they deployed IDB with the caching in mind, and this is what they got with respect to like their traffic. So this is their traffic on a per day basis. That's what they're seeing. So if you look at any particular day, let's look at this particular day where there's 1,400, there's about 900,000 queries. I click through that one. So what we'll see once it loads here is this is what the IDB shows in terms of just waiting for the screen to refresh. So what the IDB does is it distributes the queries, or it basically maps the data that we got on a per query basis and the amount of server time that we consume. So remember from a log, we have the total time that the query was taking. So what we have done is when we deduplicated the logs and aggregated it back, we can actually show you how much of these queries that are going to a particular database takes up how much time. So in this particular graph, you can see this red piece of the pie is 54% of the queries that go to the database server. But if you actually look at server time, it's only about 6%. So this gives you kind of instant visibility into what's happening on your database servers without having to enable or do anything on the database server at all. This is achieved without querying the database server at this point. So so when they were looking at performance optimizations, they started realizing that some of these database queries, like the articles database, which is in this lavender color here, is about 20% of your database server time. Whereas when you look at the server query count, it's almost negligible. It's about 0.75% of the query. So this is the kind of information that they were able to get instantaneously from deploying the IDB. So they went on to the next step, which is they started looking at each of these databases and trying to see where they can do query optimizations themselves. So let's open up the CL01 database that they started caching on. So remember this 4-quadrant graph that I had from our demo, where it was a perfect 4-quadrant graph. And now look at how the customer's graph is. This is after the caching was enabled. So there's nothing in this frequent but slow query quadrant because they've already cached all the calls that could have been cached. But typically, I'll show you another customer data here. But this is your typical customer data graph, wherein there's at least a couple of them in your frequent slow query quadrant, which are taking away most of your server time. Let me switch back to this. Hope that it's loaded back. Again, the difficulties of a WAN connection are showing up. Not loading the data as quickly as one would like it. So while the data loads, let me move on to another customer case, which is yatra.com. Yatra.com is the hotels.com site. Again, this is a marquee customer of ours in India. The reason we have some of these marquee customers in India is because IDB, our scale-up as a company, did product development in India, and we did test the markets out in India before we launched ourselves in the US in November of last year. So this is Yatra.com. Another use case for Yatra.com, if you look at it from that perspective, was to be able to figure out whether they're actually getting database optimization from some of their consultants. So this is an example of what the consultant did. So the consultant here said that they've optimized some of the queries. So there's queries going to two databases. There's the XDist database and there's the XDist air cache database. So when the consultant just showed the query logs, it looked like, yeah, the XDist air cache logs or the queries looked very efficient. But instantly, IDB was able to show that the air cache calls are actually as expensive as the non-cache calls. So instantaneously, you're able to troubleshoot and figure out whether you actually got the performance gains from your consultants or from any of the the development work that happened. So let's look at the main hour, or the 1500 or the 1400 hour for which they had scaling issues. So this is what the IDB was able to show. I'm just waiting for the screen to refresh. So this is their total traffic, the 1.3 million queries as I can look at it. So there's about 400 different types of queries. Each page that you're showing here is about 100 different queries. And you can see the IDB captures all the queries, all of it, without missing anything. And we capture even queries or set commands that are going to the database, not just the queries themselves. We capture everything. And in another use case for a customer, we'll explain how it actually helps to figure out what was happening on the database server side of things. So here, we can look at it from an analytics perspective. Of the 1.3 million queries, only the top 5 or 6 matter. Because if you look at it, we are showing the total server consumption time for each of these queries. And instantly, the customer was able to come here and figure out whether these queries are cacheable or not. So let me open up this one in a new tab, and I'll show you how they were able to do that. So while that opens up, I think it's the font size here, so you can actually start looking at some of these parameters. So you can see the customer started caching one of these queries. Instantly, they were able to go and add the pattern rule. I'll show how to add the pattern rules. But before I add that, you can see here that the IDB saw about 84,761 queries coming in. We had a cache hit ratio of about 94% once customer added the cache rule. The origin server took about 2 minutes and 14 seconds to serve about 6% of the queries that were coming in. But our cache, which is an in-memory hash-based cache, took only about 6.99 seconds to serve 80,000 queries, or 94% of it. So if you turned off caching, in effect, the origin server would take about 36 minutes additional to the 2 minutes that it was taking. So if you do a simple math, it's about 60x improvement in performance. And this is how you can simply come here from the analytics page and just add the caching rule while the screen loads. You can see that the regular expression the IDB generated on its own based on the queries that were seen. All the customer had to do was just add this time to live and then click add, and you're good to go.
And just there are some folks who joined the webinar after I reviewed the initial deployment architecture, standard deployment architecture for an IDB. And who just joined as Deepak started. And the key here is we're a transparent layer sitting in between application servers and database servers. Intercepting and distributing queries to the back-end databases. And when we're doing caching, you can cache each individual query pattern. The key is you never, ever have to modify applications to do so. So MySQL users often use memcache, which you can still use with IDB. but that always requires ongoing application modifications. Microsoft SQL Server customers would use maybe the App Fabric cache, again, requiring modifications to applications. Everything that we talk about here within IDB is done transparently to the application. So just something to keep in mind.
Okay. Yeah, and also from a SQL Server perspective, I just want to show one more thing before we move on to the next case. We can do caching even for stored procedures and prepare statements as well. It looks like our LAN connection is not working so well. But we can actually do caching for stored procedures. So when you have stored procedures, there'll be another radio button saying here, do you want to add it to the stored procedure cache, or do you want to add it to the query cache here? So with that, we'll move on to the next use case that we had from another customer regarding troubleshooting their databases, especially on an Amazon install. Justin?
Yeah. Let me take the presenter back here. Where is? You need to make me presenter, I believe.
Okay. Yep. There you go.
Okay. So we're back here, and I think we wanted to show this is a gaming customer. We've actually put some red there to hide some of the customer information. And we'd like to show you before. This is of a live production IDB deployed on Amazon in AWS. We are on the AWS Marketplace, and this is supporting an RDS customer that's running a social network for one of their games through IDB. So we can't talk about the customer's name, but we do want to show you sort of before and after. So Deepak, do you want to walk through this?
So this is a real live use case. Last week, the customer called in and said, hey, we are having slow database performance, and we would like to see what was happening. And then instantly for that hour, I mean, this is the reason it's all showing up in gray is because this is not completed analytics. Even with the incomplete analytics, you are able to see that that particular call, and I explain you what that call is taking a huge amount of time. And on the graph, you can see there's a yellow bubble, which is all the way to the right, which is showing that this is a frequent but really, really slow query. You can see relative to the other calls, which are only about a few seconds, this is taking few hours of your database time in terms of concurrent time. And what happened was the customer actually enabled slow logging even on their MySQL RDS instances, and they were not able to figure out what's going on. When they came back to the IDB was able to show that it is actually slowing down because of a set the use database command that was happening. And we were able to figure out that the use database is actually not coming from a SQL statement, it's actually coming from an application setting. So this is how quickly the IDB was able to show that at that point in time when the application was doing these calls, the RDS instances were really, really slow. So this is another use case of how you can instantly troubleshoot. And this is another hour for the same RDS instance where life looks very normal. Right? All of those queries that are showing up there are in a few minute time frames, and relative to each other, they're fairly efficient. So you can see all of them within the frequent but slow query quadrant, because we are showing these quadrants based on relative performance. It's not absolute, it's relative, because relative is what matters to most customers. Okay?
Yep, and so here's just another example of a customer called Cinchcast. This is a SQL Server customer that had a SQL Server backend, and they were supporting a third-party application that did ad serving for them for their website, Blog Talk Radio. What was happening was as the popularity of the site was growing, there were more and more customers coming on. They were starting to get errors from their database during sort of those bursts of legitimate traffic. And they went searching for a transparent caching solution that could cache some of the queries and help offload their SQL Server. They couldn't find anything out there that didn't require modifications to the application itself. They found Scalarc. We deployed IDB transparently in about 15 minutes. Instantly started caching 94% of the read-only queries. Plus, we increased, or I should say, decreased response times by 5x. So much faster responses. So we were able to scale the existing database. They're now able to do more with that database than they were before. They're serving more and more ads, so it's actually helping them generate more revenue. and just an overall win before with the transparent insertion of IDB in a matter of minutes. The other area of ROI that we talked about up front that we were going to cover is better security. So this is a small healthcare software as a service customer here in the U.S. that is hosting patient medical records for small doctor's offices. So doctor's offices with between 1 and probably 10 doctors, they're helping provide the patient medical record software as a service. So they were able to transparently deploy IDB in between their application servers and their database. This is a MySQL customer. And one of the things that they were able to do with our SQL filtering capabilities was to add a SQL level query filtering. What they did is, using regular expressions, put together a filter that said, if a query comes in and requests more than 10 social security numbers from a table, block it, because they know that none of their legitimate queries from their applications will ever need more than 10 social security numbers. So a very easy way for them to add some SQL level filtering to help meet compliance issues, and very, very easy to do transparently. Again, because IDB is sitting in between the application servers and the database servers themselves. And then finally, one thing that we did want to mention, which again isn't necessarily driven off of analytics but is identified within analytics, is the search queue. Now, I'm going to just jump back very quickly to the opening slide and talk about the architecture for a second. If you remember, IDB is transparently inserted. The application servers connect to IDB thinking we are the database. The databases connect to IDB thinking we're the application, and we're acting as a layer 7 SQL engine in the middle. Now, one of the things that we can do on the back end is control parallelism to each individual database or database instance. So in this very simple diagram, let's assume the right-hand slave that we're doing read load balancing to cannot accept more than 300 connections. If it opens more than 300 connections, the customer knows that performance starts to get really erratic. Either the performance starts flip-flopping or potentially could even crash. So what will happen if there is a large burst of legitimate traffic that would normally overwhelm the built-out capacity, and say you get a big burst of traffic and normally you would start sending more and more connections to this particular slave, and even more than 300, we know without IDB that slave would be severely affected. With IDB, though, we will ensure that no more than 300 connections are ever opened to that particular slave, even in the event of a large traffic surge. What we do is we initiate a search queue on IDB, where if we hit 300 on this particular slave, we will actually queue incoming connections, wait for that slave to be operating at maximum capacity, and then as connection availability becomes free, then we shuttle those queries in to be served. So in this particular screenshot, this is an online gaming customer of ours that experienced some major success with a recently released game. So much so that their built-out capacity was actually overwhelmed with traffic. Here, what ScaleArc was able to do was to kick in the surge queue to make sure that A, the back-end servers didn't get overloaded, and then but B, every single client request was able to get served. So it's a new level of availability, but within the analytics, you're able to see that in real time and then be able to drive in and make changes or tweaks to help with that build-out capacity. And of course, instant scalability, instant horizontal scalability with ScaleArc, being able to actually add new database instances on the fly without having to ever modify the application can help there as well.
So if you can see, the blue line is the server connections, and that does not waver at all. But if you see the red line, that's the client connections giving a search queue, and the search queue is completely handled by IDB. So the blue line does not waver at all, which helps the server from remaining stable at all points in time.
Yep. I've got about 5 minutes left, so I'm going to wrap up. Here are some of the logos of customers that are using us in mission-critical deployments. And we talked about some of the Cinchcast stuff. KickSize is another gaming customer of ours, where because of the analytics and the ability to reduce their troubleshooting time, they did not need to hire another IT operations person to do all of the data collection and log sifting, trying to find that needle in the haystack. We do that for them now. And so, driving strong ROI from just increasing overall efficiency. The other area that we increase efficiency is at the app developer. In today's database environment, app developers have to code all of the database engineering into their application. What you've seen here on this webinar is that ScaleArc allows us to abstract that out of the application and do it in our layer. And that frees developer resources to be able to develop new apps faster. We've got a new customer case study coming out with Weather Decision Technologies via a press release in the next week that we'll actually talk about as they launch their mobile application platform. Instead of having to spend 1 to 2 years rewriting their applications to be able to handle the scale out for those mobile apps, we were able to insert transparently, save them all of that time, and basically provide them for 20x scalability in the future. So please, be on the lookout for that. So that's it. In case anyone's interested in how to deploy, we do support the MySQL and SQL Server databases. We will be supporting Oracle databases in the next 6 months. And very easy to deploy our software. We are available on the Amazon cloud as well as the Joint cloud, and we'll be announcing 3 or 4 other public clouds that we'll be launching on very soon. So with that, let me stop and see if there are any particular questions out there that we can answer. Any and all questions, we'll stay on as long as we need to.
So if anybody else has any questions, you can raise your hand, let us know. Don't see any other questions. Justin, I think you're muted. So with that, there we go.
Yeah, I'm here. We're here. I'm just waiting to see. Are you sure? Is everyone else unmuted on the line?
Not yet. No, we're kind of going through it right now. Yep. So I think everybody's unmuted. If you have any questions, we've opened it up. If not, I think we're done. All right, Justin, I don't think there are any questions. We'll be following up with everybody over email. If you did have any more questions after that, we can follow up then as well. So thank you all for your time, and have a great day.
Thanks.